Good morning, everybody. This is a live tropical update with a lot to talk about this Tuesday morning. We have Hurricane Genevieve in the eastern tropical Pacific, a very powerful tropical cyclone, maximum sustained winds estimated at about 130 miles an hour. This is that hurricane right there. It has quite a large eye, very compact, central dense overcast. It's moving off to the northwest. There are tropical storm watches and warnings in the southern tip of the Baja Peninsula. But this is expected to just miss the Baja Peninsula, including Cabo San Lucas. It is expected to further intensify, even potentially reaching Category 4 strength in the next 24 hours. This is the official hurricane track here, and this is using the tracking tools of RadarOmega here, and this is a very powerful hurricane lifting off to the northwest, and this storm is also going to energize the southwestern monsoon season. We have seen an uptick in that monsoon season as the anticyclone has migrated a bit west toward the Four Corners region of the Great Basin of the United States. And that allows for the return flow on the west side of that high to pump that moisture northward from the eastern tropical Pacific and the Sea of Cortez. That's resulted in some dangerous flash floods, even a haboob across southern Arizona. And Genevieve is only going to result in a major uptick in that moisture getting infused into the southwest U.S. Overall, though, this storm is going to just miss Cabo San Lucas in the next 24 to 48 hours. Right now, it's well east of Jalisco, Mexico, due west-southwest of that location. The red marker there is when the official NHC forecast has that system, Genevieve, reaching a Category 4 just off of Sinaloa. And then this right here is the Baja Peninsula, and you can see that tropical cyclone curving west-northwest out to sea, moving into cooler ocean temperatures, and then a quick weakening. But it is going to pump moisture northward up through the Sea of Cortez into southern Arizona. There's even a marginal risk up there for severe weather in the coming days as that moisture gets transported northward into the Sea of Cortez. Now I'm going to show you the satellite here of Genevieve. There's likely going to be some big-time debris flows as well off of those burn scars in Arizona. The Bighorn burn scar, that is a big one that David Rankin observed some debris flows off of recently with some severe storms in southern Arizona. That's just outside of the Tucson area. And look at this eye on satellite, through the high-resolution satellite imagery here. You can also see some supercell storms in the outer bands, a bit of a moat on the outside of that central dense overcast. But this is a pretty large eye. And that's why it is forecast to intensify quite a bit. The conditions are quite favorable here over the eastern tropical Pacific. Weak wind shear. And this is a large eye that has a lot of room to constrict, become a much smaller, compact eye. And that's why this storm is forecast to become a Category 4 in the eastern tropical Pacific. And this storm and the outbreak of tropical cyclones that has happened at recent over the eastern tropical Pacific is correlated with the Madden-Julian Oscillation, or the MJO as we call it. And that's an area of enhanced rain and convection that will propagate around the globe, arriving all the way back to its original position in a period of about 30 to 60 days. And there's a Kelvin wave that moves a little bit faster. There's the MJO that's a little bit slower. But how you categorize the MJO is mostly semantics. You can split them into those two different periods. The Kelvin wave, which is a faster wave that goes around trapped by the equator, rotating around the globe in the tropics. And the MJO overall modulates tropical cyclone activity across the globe. It exists in what we call a dipole, where you have an area of sinking motion, for example, across the western Pacific. That acts to suppress the convection out there and suppress the tropical cyclone frequency. Meanwhile, on the other hemisphere, on the other side of the globe, you get an uptick in the convection. You get enhanced lift, you get more divergence aloft, and that leads to weaker wind shear across that tropical basin, and you get an uptick in convection and tropical cyclones. And that's exactly what has happened here over the eastern tropical Pacific, as that Madden-Julian Oscillation, or uptick in convection, has propagated over the eastern tropical Pacific. And it just now is starting to bleed into the Atlantic Basin, and that's what all the meteorologists have been talking about, how we expect the end of August to be very active across the Atlantic Basin. We already have 2 storms out there, likely indirectly related to the MJO. We just recently had a downtrend in the convection out there in the Atlantic Basin after a very active start in July with Hurricane Hanna, Hurricane Isaias. That was at the tail end of the last MJO uptick in convection across the Atlantic Basin. Then we had subsidence that dominated the Atlantic, and now we're starting to get that increase in convection across the Atlantic Basin, and that's what we're analyzing right now. And here is that track for Hurricane Genevieve, forecast to become a major hurricane. You can see those alerts that include Cabo San Lucas. May get some tropical storm force winds there, as this storm is going to come very close to the Cabo San Lucas area. The last advisory had maximum sustained winds estimated at 130 miles an hour, minimum pressure down to 950, and it is expected to intensify as it moves off to the northwest. And here are those intensity forecasts by the hurricane models, and this shows intensification into a strong Category 4 storm. Maximum sustained winds expected to reach at least 145 miles an hour as the storm moves just offshore of Cabo San Lucas. All of the forecast model tracks show this storm system being offshore of Cabo. So the forecast track is pretty certain off to the west-northwest, but still pay attention to this. If you do live in Cabo, there's definitely going to be impacts out there. And now I want to discuss the Atlantic Basin. And so we're going to just give a summary of the storms of interest that we're tracking in the Eastern Tropical Pacific and the Atlantic Basin. Then I'm going to give a quick summary of the field science mission that we have planned for hurricane season. A lot of that is made possible by you guys, Facebook supporters, so thank you so much. We have the subsonic sensor. We have little instrument packs that we're going to deploy for RadarOmega that stream live pressure data and also wind speed data and cameras of that storm surge. We also have the Windy Palms project, which is Mike Tice's project that he's been planning for years, if not decades. And that's where we're going to mount instrument packs on the top of palm trees because those trunks of palm trees are often left standing when these powerful hurricanes move by. So it's a way to kind of utilize nature to capture that incredible data. Any data point inside these powerful hurricanes when they make landfall is incredibly valuable. And that's our general plan with the science mission. I'm going to give an overview of that and a discussion of the MJO. I'm going to define it. I'm going to show it propagating around the globe. I'm going to show some forecasts as well. And the MJO is different than El Nino because El Nino is a stationary phenomenon, largely sea surface temperature related with an atmospheric component that is stationary in the tropical Pacific, and that will exist on the order of 1 to 3 years. Whereas the MJO is an intra-seasonal phenomenon, so it oscillates on the order of weeks to months around the globe, and it's a way to kind of bridge the gap between those shorter-term forecasts of 7 to 10 days by the numerical model guidance, those supercomputers, and also the seasonal forecasts that are largely statistics and utilization of the MJO and other features in these intra-seasonal forecasts. Is basically a hybrid approach using the dynamical models and statistics and all these ingredients put together to basically predict an uptick in tropical cyclone frequency by oceanic basin as these MJO or /Kelvin waves will propagate around the globe. So these are the two disturbances that we're watching in the Atlantic. There's the eastern one, which is further out. That's given a higher likelihood of development, at least according to this last graphic. And then there's the western one, which this morning is starting to look even a little bit more favorable on satellite. That's just to the north of the South American coast. But long-range models are showing both of these storms to move into the Caribbean, maybe even the Gulf of Mexico. This eastern one could threaten the Florida mainland. And I wanted to show you why these systems are going to move more west as opposed to becoming fish storms. And this is the model imagery here from Tropical Tidbits. And this is the long-range forecast showing the surface high pressure. This is the Bermuda High, the Bermuda Azores High here that's stretched across the subtropical Atlantic. And the position of this high and the shape of it will determine whether most of the storms recurve on its western periphery, impacting maybe Bermuda, often curving harmlessly out to sea. And you can have very active seasons in the tropical basin where every single one of these storms will recurve as absolute monsters out there and become fish storms with minimal impacts to land. But when this Bermuda High extends a little bit further west, into the Atlantic toward the southeastern coast of the U.S., even further west from there. It encourages the tropical cyclones that form in the intertropical convergence zone out here in the tropical Atlantic to continue west into the Caribbean Sea, impacting portions of the greater Antilles, and maybe even moving into the Gulf of Mexico. And as we've seen throughout the weather briefings this season, the water temperatures are extremely warm here in the Caribbean and the Gulf of Mexico and the tropical Atlantic. So any storm that does make it this far west has the potential to become a monster storm that could have United States impacts. So I'm going to step forward with time. This is present. And notice how that high, it looks like it tries to propagate to the east, but then you see that western expansion. Look at that lobe extending all the way to the southeastern U.S. In fact, some geopotential height anomalies out here. These are HPA anomalies here, so you can see some high pressure that wants to anomalously high pressure on the western lobe of this Bermuda High. That shows that this Bermuda High is extending unusually far to the west, and that will encourage these storms to recurve a little bit further west and even have U.S. impacts. This is by August 24. Look at that westward extension of the Bermuda High, well west of Bermuda, all the way to the southeastern U.S. And that's why I expect any of these disturbances that form in the Atlantic to potentially have U.S. impacts, and that's why we're watching it so closely. So now I wanted to give you first of all, let's look at these disturbances out in the open ocean using the RadarOmega app here. You can change the view off to the entire Atlantic Basin to see these disturbances in action. We use visible satellite, as of course it's very bright out there. And boy, since daytime hours. Here you can see these two waves. These are the ones that we're watching. You've got this one just off the coast of Venezuela. It actually looks a little bit less favorable than it did when I first pulled this up about an hour or two ago. That's as we're getting into the middle of the day. You usually get a convection minimum, and then overnight, as the sea temperature and the overlying atmosphere has a greater temperature difference, you get an uptick in the convection. So usually these waves will blow up overnight, and then during the day look a little bit less favorable. This right here is the furthest out wave. It's well west of the Lesser Antilles. This wave looks a little bit less organized than it did earlier. It's got a couple of different vort centers. It does look like this one, though, is starting to dominate, but basically just an elongated area of west to east vorticity that has yet to develop a closed center. That's why it hasn't been named a tropical depression yet. This one right here looked a little bit more compact, and the fact that it looked like it had a bit more of a closed rotation, but we're starting to see a decrease now in that convection. And these are both just tropical waves with a high likelihood of development. And different than last year, where during peak season these storms would ramp up to powerful hurricanes, even to the east of the Lesser Antilles, caused a lot of destruction across the greater Antilles and portions of the Lesser Antilles. This season seems to be a little bit different, where these storms are battling a little bit of hostility in the environment way out in the Atlantic. Of course, it is earlier in the peak season, but then they're waiting till they get to the Caribbean, where they could intensify. The upper level wind shear is forecast to remain weak for these systems. Sea surface temperatures are warm in the Caribbean and the Gulf of Mexico, and for that reason, we do expect these to become tropical cyclones as they move off to the west. The Atlantic Hurricane Center does, or the National Hurricane Center does as well. And this gives you a better idea of the robustness of the convection. And earlier, this wave to the north of South America had a little bit of a convective blob over it as we woke up in the morning after the convective maximum starting to subside a little bit. But you can see that this is mostly just an open wave. There's no closed rotation with this. This is an easterly wave. You can see the cyclonic vorticity there with the southerlies on the east side of this easterly wave, northerlies on the west side. And as soon as we start to get some westerlies shown here, then that's when it's starting to develop a closed circulation, and that's when it'll become a tropical depression. But right now it's just an open easterly wave. This one, this western vortmax is starting to look a little bit more favorable. There could be some westerly winds even in here, so I wouldn't be surprised if this is named a tropical depression later on today. But those are the two disturbances. There's a blob off to the east. Isaias had this as well, kind of two blobs as it was organizing, and then the western blob took off. This one looks like it has less rotation, less vorticity than this western one, so the western vortmax is probably going to dominate and become that center. But both of these disturbances could have problems and could pose threats to the U.S. This western one definitely could, the forecast models are taking it pretty close to the Yucatan Peninsula and then possibly out into the open Gulf of Mexico. And all of that is because this westward extension of the Bermuda High that's going to evolve over the next 5 to 10 days. As that Bermuda High builds west toward the southeastern U.S., that's going to prevent and block these storms from recurving and becoming fish storms. So now I want to show you a little bit of our science that we're going to be having planned for these hurricanes. These are some new pods that have been designed by Don Murray at RadarOmega. These are live streaming pods. They have a camera on there, GPS position, as well as wind speed and pressure data. And we're going to install these in an array along the coastline, including some storm surge prone areas, basically to behave as storm surge cams. And we're going to be streaming this data to the RadarOmega app, so you'll be able to see this data play out in real time. The plan is to lay this out as a network out ahead of the hurricane. We're also going to be using the iPhone app as well. There we go, the screen was stuck just for a little bit there. But this will be a pressure sensor that are built in to the smartphones, and this will also be a way to measure the pressure fall inside these hurricanes. We also have the Windy Palms project. This is the brain child of Mike Tice, and you can see there's some RM Young anemometers, some other sensors in there. We're going to be Mike is going to be skinning up palm trees and mounting the Windy Palms in the top of those trunks to record incredibly valuable data inside these storms as they come in. So we're going to have the Windy Palms, we're going to have those pods from the RadarOmega app. We're also going to have the ground-based probe that we're trying to deploy inside tornadoes this season for Cat 6. And we're also going to have the most exciting part as well, the subsonic sensor. That's what Mark, or Chase and Spin, has been working on for months. And that basically measures the heartbeat of the hurricane, tornadoes, or other storms. And we can deploy that inside the eye where there's a minimum of precipitation. And that will measure basically the subsonic or really low frequency sounds emitted by these storms, including hurricanes. And we'll deploy that inside the eye because you need basically calm winds to deploy this sensor, because any wind passing over the probe will generate a pressure signal, and that will act to wash out the subsonic frequency that we're trying to capture with the subsonic sensor. So our goal is to deploy these inside the eye of a powerful hurricane, see if there's an indication of storm surge or mesovortices that are rotating around the inside of the eye. The RadarOmega project we're calling Project Mesovort. The goal is to set those pods in an array out ahead of the eye wall so that we can try to sample those mesovortices or those tornadoes that are happening, and that'll be streamed in real time. So we basically got the trifecta of science projects ahead for the intercept of these tropical cyclones. And so I've been told that there was a freezing up of the live stream, so I wanted to go back here and break down these disturbances that are in the open Atlantic. So these are the two disturbances, as I mentioned. This is the infrared satellite. This is the one that's further out to sea, and you can see there are two vorticity centers with that wave, but it looks like the western one is starting to dominate just a little bit. That's this one right here. And once you start to get closed rotation and an indication of westerlies or southerlies in there, because you have a lot of easterlies with these easterly waves, that's when this will be named a tropical depression. This one to the east is more of a classic open wave right now, but this one also has a high likelihood of becoming a tropical cyclone over the next 5 days. There was a convective explosion overnight with this one just to the north of the South American coastline. Make sure that This thing isn't frozen, and it does look like it's made it. So this is the main development region. This is the intertropical convergence zone, this area that develops every season this time of year, and you get the easterly waves that come off the coast of Africa. But the Madden-Julian Oscillation, as we discussed earlier, is basically an area of enhanced convection, divergence aloft, increased low-level convergence that propagates around the globe across the different oceanic basins in the tropics on a 30 to 60 day periodicity. So it goes all the way back to the original position on the globe, returns back to its original position on the order of 1 to 2 months, sometimes even faster than that, depending on the behavior. But that led to the uptick in hurricanes across the eastern tropical Pacific, and it's contributing to the uptick in the intertropical convergence zone here in the open tropical Atlantic. And these are the two disturbances that we're watching very closely. Both of these are forecast to enter into the Caribbean and potentially the Gulf of Mexico, and that's because of that westward extension of the Bermuda High that we were just showing all the way to the southeastern coast of the United States. And that's going to block these storms from recurving off to the north and becoming fish storms. And that's why we have to watch these so closely, because they could very easily have United States impacts. So now I'm going to discuss the Madden-Julian Oscillation. This graphic here is from the climate.gov website, but this basically shows the very general fundamentals of the Madden-Julian Oscillation, and it exists as a dipole. So you have an area of sinking motion over often one hemisphere or one whole oceanic basin. That sinking motion leads to a decrease in the convection across that ocean basin. And then at the same time, you also get an uptick in the convection on the other side. You can't have just subsidence across the whole entire globe, or else you're not going to really have any heat transport aloft in the atmosphere and to the poles. So this Madden-Julian Oscillation will propagate around the globe. It's almost like it gives an ocean basin a breather after being really active with convection for a whole entire season. I've got a bunch of graphics here that I'm going to show you. Trying to bring these up front and center right now. But they propagate from west to east across the globe, even though at the low levels you have these easterly waves that move from east to west. These are lower frequency oscillations of enhanced convection that will go from west to east along the equator, trapped by the equator. That's why there is some debate as to whether these are Kelvin waves, which are basically propagating waves that are trapped by a barrier, whether it be a mountain range or the equator down there, which basically behaves like a mountain range, trapping these waves as they propagate around the globe. And this part here shows the uptick in convection. You get an enhanced, anomalously high upward motion. You get anomalously high divergence aloft. That's why we use that 200 millibar velocity potential as a measure of the divergence and convergence aloft, anomalous divergence and convergence. And this is the anomalous convergence at the surface, which enhances convection. And usually most of the convection is found in the western Pacific. So you'll get a bunch of typhoons out there in the western Pacific, and then a little piece of that convection will break off, and then it propagates around the globe. Right now it's reaching the eastern tropical Pacific and starting to impinge on the Atlantic Basin, this upward portion of the dipole that is the Madden-Julian Oscillation. And this was discovered by, of course, Dr. Madden and Dr. Julian a long time ago, as they were analyzing El Nino and noticed a intraseasonal period in wind max and the trade winds, and also the divergence and convergence located aloft in the atmosphere. And while El Nino varies on an order of 1 to 2 years, or even longer than that, in the Pacific Basin, and it's a stationary phenomenon out there, closely coupled to sea surface temperature anomalies, which vary much more slowly than the overlying atmosphere. The Madden-Julian Oscillation is more of an atmospheric circulation. It also is modulated by sea surface temperatures, but propagates from west to east on a period that is quicker than the El Nino. So you can have El Nino conditions or La Nina conditions in the Pacific, but you still have this region here that will often encompass a whole entire basin of increased upward motion, increased convection, and as I mentioned, that is propagating over the eastern tropical Pacific into the Atlantic Basin, as many meteorologists have discussed. And there are many different ways to visualize the Madden-Julian Oscillation. and plot it, track it, and the meteorologists will split these into different phases depending on where the uptick in convection is located. And right now, basically phase 7, 8, up to phase 1, even phase 2, represents an active phase across the eastern tropical Pacific and the Atlantic Basin. And that's the phase that we're getting in right now. And that's why we expect an energized intertropical convergence zone, more convection across the Caribbean and the Gulf of Mexico. And we've got that outbreak of hurricanes across the eastern tropical Pacific. These phases, on the other hand, 3, 4, 5, these phases here represent inactive periods for the tropical Atlantic, as you have sinking motion, you have anomalous convergence aloft, you often have a hostile environment across the tropical Atlantic characterized by increased wind shear and decreased convection. But while that's happening, it's very active across the Indian Ocean, portions of the Western Pacific, and this is actually that enhanced convection associated with the Madden-Julian Oscillation slowing down in the Western Pacific and the Eastern Hemisphere. It moves a little bit slower. That's because overall, on average, you just get a lot more convection across the Western Pacific. And then you can see the subset of it beginning to migrate across the open Pacific, reaching the Eastern Tropical Pacific and the Atlantic by phase 7 and 8. And so that's what meteorologists will use to track the Madden-Julian Oscillation and try to predict these upticks in tropical cyclone frequency. Another way to visualize the Madden-Julian Oscillation is using a variable called 200 millibar velocity potential. And that basically represents convergence or diverging air at the upper levels of the atmosphere at 200 millibars. The green here represents anomalous divergence aloft, or an increase in convection, whereas this, the orange color, represents dry or a decreased convection. And this, you can see the dipole. So you've got an increase in convection over here, Eastern Tropical Pacific into the Atlantic. You get a decrease in convection over here, and that's that dipole that we discussed. That is the Madden-Julian Oscillation. And this is phase 7 and 8. Right now, this is around August 17. You can see the increase in convection that basically has indirectly resulted in Hurricane Genevieve, and it's starting to move over the Atlantic Basin. You can see the forecast toward the end of August, and even toward the beginning of September shows a pretty active Atlantic Basin in terms of convection. And then you can see it starts to appear over the Indian Ocean by September. The really long range looks like by September there could be an unfavorable phase in the Madden-Julian Oscillation. And this shows that by the month of September there could be a decrease in that convection across the Atlantic Basin. So here at the end of August is probably when things are going to be really active, including the potential for United States threats. And then you've got a period here extending through September where it could be relatively inactive across the Atlantic. There's probably going to be some tropical cyclones in there just because it's that time of year, and it doesn't mean that this is going to be an on-off switch where you get a complete cessation of tropical cyclones out there. But it does look like the Western Tropical Pacific is going to become more active next month. Maybe that'll mean more tornado chasing, more fall season action across Tornado Alley and across the U.S. That's kind of what happened last year too, when the fall season picked up during an unfavorable period in the MJO. Still probably not much of an observed correlation between mid-latitude severe weather and the MJO in the tropics, but we'll hand wave that. So the 200 millibar velocity potential basically represents whether there's convergence or divergence aloft. And when you have enhanced convection out here, that means that you have enhanced divergence aloft, enhanced convergence at the low levels. And basically you have a lot of storms and tropical cyclones that are contributing to the transport of heat aloft in the atmosphere and toward the poles from the equators, from the equator toward the poles. And that's really the role of tropical cyclones on this planet. Another way to visualize the Madden-Julian Oscillation is through outgoing long-wave radiation anomalies. And basically the blue color here represents colder cloud tops, increased deep convection across the, look at that, across the eastern tropical Pacific, even though we have a La Nina that's developing, slightly anomalously low. sea surface temperatures. We still have increased convection associated with the Madden-Julian Oscillation at periodicities quicker than ENSO will evolve, more closely coupled to those sea surface temperatures. But this is showing the 11 to 15 day average is showing some favorable conditions across the eastern tropical Pacific and the Gulf of Mexico and Caribbean, continuing through the end of August towards September 1st. And you can see the dipole, but look at the convection starting to build in the Indian Ocean as we exit this phase closer to September 1st. Probably going to be some tropical cyclones that impact Bangladesh there, maybe southern India. Definitely an uptick in convection though, and a period of dry across the western Pacific, which will increase as we go through the middle of September. And this is a plot that meteorologists use. That you remember that diagram I showed you with the different phases, 1 through 8, with basically 1, 8, 7 being quite favorable for convection in the Atlantic Basin and the eastern tropical Pacific. And that's represented by these. And these are model forecast ensembles here. And you can look at all these different global models ran by the supercomputers. But general agreement is for an uptick in convection in the western hemisphere, including the tropical Atlantic, the eastern tropical Pacific. And that's exactly what we're observing right now through satellite with Hurricane Genevieve in the eastern tropical Pacific coming just west of Cabo, and those two disturbances in the Atlantic. And at this time, when you have an uptick in the western hemisphere in Africa, you get a decrease in convection across the western Pacific, across the Indian Ocean, across the continental maritime regions too. So this is a good plot that has been put together by meteorologists to track the MJO and also work in some forecasts using the global models to see how it's going to evolve with time. This is kind of a combination of statistics where it meets numerical weather prediction, and this is the intraseasonal part of forecasting. This is between those 7 to 10 day forecasts we use so often in severe weather and those really long range seasonal forecasts that use a lot more statistical variables and teleconnections to produce sea surface temperature anomalies. You'll definitely use ENSO forcing in those longer range forecasts because ENSO evolves, or El Nino and La Nina evolve on the order of 1 to 2 years. So this is my general discussion of Madden-Julian Oscillation. I hope that helps it make a little bit more sense and kind of bridge the gap between weather and climate just a little bit and give some physical reasoning behind this uptick in activity that's anticipated for the Atlantic. But just because we expect an increase in activity, the behavior of these individual storms is still largely going to be impacted by their interaction with land, the mountainous terrain over the Greater Antilles and the Yucatan, the arrival of Rossby waves across North America and whether it can pick up and turn these storms to the north. But one thing is for certain, the western extension of that Bermuda High close to the southeastern U.S. is going to act to block these storms from turning out to the north and becoming fish storms with primarily a Bermuda impact. So this is my tropical update for this morning. I'm planning on getting the Dominator 4 waterproof today. I'm getting a piece of sheet metal welded over the sunroof and over the back window. That's going to happen tonight. I'll be sure to go live and show that process as well. And then the plan is if one of these storms shows potential for landfall across the U.S., that's when I'm going to drive Dominator 4 into position with the probe. The subsonic sensor is getting shipped to me this week. Don is building the live streaming probes in Atlanta. I'm probably going to have to swing through there and pick those up. Mike is working on Windy Palms with the HERV in the Florida Keys, and we're all going to meet up to intercept this storm with the number one goal of doing science and collecting data inside these hurricanes, and that is largely made possible by the Facebook supporter community. So thank you everybody for joining me today. I hope this was informative. I hope you guys overall enjoy my weather reports, and have a great rest of your Tuesday. Thank you everybody. Never stop chasing.